We are on the module Introduction to Big Data Techniques, and we only have 3 learning objectives here. First one is to describe aspects of fintech that are directly relevant for the gathering and analyzing of financial data. We can do that one quickly. Describe big data, artificial intelligence, and machine learning, and we have brief introductions to these. You'll see big data and machine learning more at level 2. And finally, describe applications of big data and data science to investment management. So let's begin with just a big, broad definition of fintech. Technological innovation in the design and delivery of financial services. So there's the tech, there's the fintech. And it is characterized by 2 big themes: the analysis of large data sets and the type of analytical tools. So for large data sets, we have both traditional and alternative data. You could think of traditional data as well. Anything you'd find on a company's balance sheet, income statement, cash flow statement. You can think of all the economic reports we get: GDP, retail sales, housing starts. Alternative data, social media, sensor networks. These are just examples. The list can continue on. Analytical tools that we would use for extremely large data sets. AI, artificial intelligence. Machine learning is also a very powerful tool that's used as well. You'll see more of that at level 2. Very useful for complex nonlinear relationships. Let's move on to the first one here, analysis of large data sets. Let's talk about big data. Data generated from traditional and alternative sources. Characteristics of big data. Usually they call it the 3 V's, but there are actually 4 of them here: volume, velocity, variety, and veracity. And we can see here that there is a trade-off between veracity, which is the truthfulness or the credibility of the data, versus the volume of the data, the quality versus quantity issue. So volume, you're talking about millions to billions of data points. And previous to I'm going to call it the modern era here, the last 15 or 20 years or so, previous to that, there had always been lots of data out there. It was a matter of how do you analyze all that data. The computing power 30 years ago simply wasn't around to analyze all of that data. Well, now it is. Velocity, the speed of recording, transmitting, and generating has accelerated to real-time and near real-time data collection. Variety, text, image, speech, video, and veracity relates to the credibility and reliability of different sources. And because we have an internet that is democratic in the sense that it is open to all voices can contribute to the vast amount of information that's available out there. Well, how credible are some of those voices? So you may be doing a Twitter scrape where you're scraping off messages that have certain keywords in them. Well, they come from sources, and those sources have no editors. In other words, they can post whatever they want. So you have to have some method of saying, well, how much faith do we put in the validity of this data? Okay, data can be structured, unstructured, or semi-structured. By structured data, we mean that it can be organized in tables and database entries. Unstructured cannot be represented in tabular format. Think about voice and images. However, here's the deal. To do any kind of work on unstructured data, you have to find a way to give it structure. So all data must be structured before use. Sources of data: financial markets, business, governments, individuals, sensors, and Internet of Things. So for financial markets, you can think of traditional price and volume data. Businesses, you have the SEC filings, press releases. Governments, big on releasing economic data. Individuals, web footprints, transactional data, credit card data, for example. Sensors, images, traffic volume, and the Internet of Things, smart buildings, appliances. A good example here, I have a Nest devices in my house, both for smoke detector and for heating and cooling. And there's an app that you can download to your phone so that if I'm out, I can adjust what's the temperature in my house. If I say, well, I'm not going to be home for another 6 hours, I can, in the winter, I can lower the heat to save on energy, and then I can raise it all from my device. And if one of the smoke alarms goes off, my phone, no matter where I am, my phone gives me alert that one of them are going off. And these are all connected through the internet. So you can start thinking about, well, what if your appliances have that feature as well? And there's a lot that you can pre-program in, even if you're not in the home. Just from the app, you can change, you can have the devices operate at certain times, turn down at certain times. Three main sources of alternative data from individuals, business processes, and sensor data. Individuals, text, photos, audio, website clicks, website engagement. Business processes, sales, credit card data, something called corporate exhaust. This is just data that's generated in the natural course of a business doing what it does. So things like supply chain information, the volume of shipping that happens to be going on a particular route, for example. Point of sale scanner data, and the sensor data, smartphones, RFID chips, and this includes the IoT, the Internet of Things. This includes the array of physical devices that happen to be connected to the Internet. And more now, vehicles are being connected to the Internet, that you have a vehicle that is a connected device on your network. There are some clear ethical and legal issues involved with collecting certain types of data. What if you're collecting data without the user's knowledge that their usage patterns or their footprints are creating data that you happen to be using? So the use of personal information or data scraped from web data. Challenges, and this is really related along three dimensions: the quality of the data, the volume, and the appropriateness. So you can think of issues like selection bias, missing data, outliers, data cleansing and organizing. For outliers, what do you do with them? Are they appropriate? Should they be in the data set even though they're outliers? Or are they going to be misleading and they should be deleted? So some subjective assessment is required. AI, artificial intelligence, systems that exhibit cognitive and decision-making ability, and I think this is a bold statement here, comparable or superior to humans, from expert systems to neural networks. An expert system is just a bunch of if-then rules. For neural networks, this is based on how brains learn and process information, that you have a certain input. So let's say I write this down, and a computer has to recognize that as the number one. How does it go about recognizing that as the number one? Well, there are certain functions, certain parts of it. So it may take a picture of this section, a picture of this section, a picture of this section, and feed it through to these three. And these three may then break it down even further and send it to other decisions. And if it matches a particular pattern, it gives us an associated probability, which then starts to feed through to a couple more. And then finally, you get an output with a certain probability. So all of these in here are called hidden layers. So you have some input, you have hidden layers, and then you have your output, which is the probability associated. It may say, okay, 98% probability that it's a 1, so the computer then makes the decision that it's a number 1, and that is included in the rest of the text that it reads. And then maybe that's part of a larger system that analyzes the meaning in the text and then has some kind of interpretation of what it is. Machine learning seek to extract knowledge from large amounts of data without assumptions of the data's underlying probability distribution. If you've done any statistics before, if you've done something called factor analysis, that is a small sort of example of trying to extract some structure out of the underlying data without assigning structure to it at first. Seeing what the algorithm or what the program can find on its own. You can learn from known examples to determine the underlying structure in the data, and you attempt to generate structure without help from a human. Well, since this module is called Introduction to Big Data, it shouldn't surprise us that we require large data sets. We require large training data sets specifically. So if you have a data set, you have to split it into 3, and your training data set must be significantly large. On top of that, you need a validation data set and a test data set. So it starts to give you an idea of how much data you really need. Training data You can input labeled data, which means you have inputs and outputs. So let's say that you're trying to detect credit card fraud. What is going in here might be 10 million transactions. And in those transactions will be all the legitimate transactions and the fraudulent transactions, so that the algorithm can identify the fraudulent ones and try to find a pattern in those fraudulent ones to see if it can then detect what that pattern is. And then you would validate on another part of the data set without telling it which ones are fraudulent to see if it can figure out which ones are in fact fraudulent. So you have to start with, hey, listen, here's the successes. Here are the failures. What can you glean between the difference of successes and failures? Come up with your algorithm, and then we'll move you to a data set, but I'm not going to tell you which one the failures are. Let's see how good you are at predicting. And then here, that's where the model is validated and tuned. In other words, if it doesn't perform well out of sample, you have to go back to the training data set and try something different to see if it can predict well here. And then once you validate it, let's test it on another completely different data set. So when you have data going into a training data set that has both inputs and outputs, this is called supervised learning. Let's just jump down here. You can have something called unsupervised learning, where there's only inputs, no outputs. Let's get back up here. Supervised learning, over or underfitting. If you overfit in the training data, because you can get a model that can fit it really nicely. It will not perform well out of sample, which is why you have to validate it. And then once you've got your model, then you finally have to test it. Deep learning, multi-stage nonlinear data processing, can be supervised or unsupervised. Doesn't go into a lot of detail about deep learning. Here, you're really dealing with neural networks. You'll see more of this at level 2. Data science is the combination of computer science and statistics to extract information from big data. Okay, let's look at data processing methods. Imagine that you were tasked with collecting a bunch of information about something and coming up with some sort of outcome. All the different things that you'd have to think about. Well, how do you capture that data first of all? And this, we're going to use the word latency here, the latency of the system. Do you need a low latency system? In other words, I need the data as it happens. Or can you have a high latency system where you say, look, it's not important, the timing isn't important, it's the existence of the data that's more important. Curation, ensuring data quality and accuracy. Which is a big deal, especially when you get to alternative data. How do you ensure that it is actually good data and not just ridiculous ramblings of anybody on the internet that can post anything they want, right? Detect errors and make adjustments for missing data. How are you going to store that data? Remember, we talked about non-traditional data in the form of text or images or video. Well, how are you going to store that data that is then searchable, right? Record, archive, and access the data in a database. Remember, at the beginning of this, I said that you can have unstructured data, but to work with it, all unstructured data must at some point have some structure. How the data are queried. Imagine that you just had a whole bunch of videos, and you say, well, I'm just going to store a whole bunch of videos. And you say, well, how many times was the word Jurassic used in these videos? Well, how are you going to do that? How are you going to find a way to do that? You'd have to have some structure to these and some tags associated with them so that you could find those things very quickly. And transfer, the movement of data from storage to analytical applications. Data visualization, how data is formatted, displayed, or summarized in graphical format. So there are heat maps, tree diagrams, network graphs, tag clouds. You may be more familiar with the term word cloud, and this is for text data. Words are sized or displayed based on frequency. Text analytics, the use of large unstructured voice or text data sets. Combine that with what we talked about on the previous screen with word clouds. So you could have an algorithm, for example, listen to a Q&A session with an important market participant, and then that algorithm would extract a word cloud from that and give you a visual presentation of the words that are used, with the words that were used more frequently displayed at a larger size. So you can get, you can see the 4 or 5 big words right away. You can get an idea of the theme and the content of what the Q&A session was about. Natural language processing. Here you're going to take computer science, you're going to overlap it with artificial intelligence, and you're going to get a linguist in there, and there you go. There is natural language processing. Computer science plus AI plus linguistics, analyze and interpret human language. For translation, from one language to another language, not as easy as you think it would be, and speech recognition, so that rather than type out my emails, I can simply speak into a microphone and it would type it out for me. You can do this with videos. You can put my video through a speech-to-text algorithm, and I've done that to see if it's valid. And the amount of editing I have to do after the fact becomes very difficult, because in finance we have very particular words, very particular acronyms that we use that may not be recognized in speech recognition. So it's not superior to a human yet. The speed of it to give you the original text that you would have to edit is super fast. Yeah, that's better than a human. But its precision leaves much to be desired.